So let's look at another example of finding the volume of a shape that we're familiar with, in this case a pyramid. And we're going to have a pyramid that has base of 6 by 6 and a height of 9, so it has a square base. And notice we just went ahead and put it on the coordinate system. I just think it's easier to deal with that way. So notice the base here would be from -3 to 3, so it has a base of 6. This length would also be 6, and then the height is 9. Okay, so we're going to find the volume of this. Now, of course, we do have a formula for this, but those formulas came from somewhere. We're going to kind of pretend we didn't know what that formula is and try to find the volume of this using integration. But just so we can check our answer, let's figure out what the volume should be using that formula. And the volume for a pyramid is 1/3 base squared times height. Okay, so, and that's of course because our base is a square. So we have then 1/3, the base is a 6 by 6, so 6 squared times 9. So let's see, that would be 36 divided by 3 is 12, and 9 times 12 is 108. So that's what we should end up getting when we're done, 108. So we are going to use cross sections to find the volume of this pyramid. So let's go ahead and think about which way we would want to slice the pyramid. If we slice with respect to the y-axis, let's just think about what shape that would be. So if I take a pyramid and I cut it along this way, let's see what that would look like. Okay, so there's one of the slices, and I see that it's going to be a square. Right, because I have a square base, if I slice anywhere, I'm going to have a square as the cross section. So if we had done the other way, that is, if instead of slicing this way against the y-axis, if we had chopped with respect to the x-axis instead, I just want you to think about real quick what those shapes would be. You might even want to just pause it and maybe draw some sketches and kind of think about what that shape would be and come back. So if I chop this way, I'd end up chopping down, like so, across, down, and across. And I know the way that it looks right now, it kind of looks like a square or a rectangle, but think about the dimensions here, because the base of this cross section would have a width of 6, right? It goes along the entire base. But the top of it would have a different length because it's narrower up here. So it actually would end up being like a trapezoid. Like that, it'd have a longer base than at the top. So it would end up being a trapezoid if we went perpendicular to the x-axis. Now, since I don't necessarily know the area of a trapezoid off the top of my head, I know there's a formula out there, but a lot of us don't remember that one, and the shapes are varying quite a bit. So let's go ahead and do with respect to the y-axis, because I definitely know how to find the area of a square. So to find the area of this cross-section, well actually let's take a look first at what the widths of the cross-sections are. So I see that the widths are going to be some change in y. Let's go ahead and draw cross-sections out here. So there's one of the cross sections. And like I said, I see that the widths of the cross sections are some change in the y-coordinate. So that means that when we set up the integral, we're going to want the area of the cross section to be in terms of y so that we can integrate. So let's try to figure out what these dimensions are. If I look at the middle here, so this y-axis would go right through the middle of this cross section. If I look at this length from here to here, I can see visually that that is going to be whatever the x-coordinate is at that point, right? So for example, if I have my cross-section down here where y equals 0, I see that this distance would end up being 3, and that's exactly what the x-coordinate is at that point. Notice up here, the cross-section would have, this distance would be 0. That is also the x-coordinate at that point. So I see from this distance outwards, that distance is x. So notice then if this distance is x, then this whole distance would end up being 2x. And since it's a square, I know that this distance is also 2x. So that means that the area of the cross-section is 2x by 2x, or 4x squared. So that's the area of all of the cross-sections. That's what we're interested in integrating. I want to add up all of the areas of these cross-sections. But I need to do so with respect to y, because that's the width of the cross-section. So that means that we're going to need to figure out how to rewrite this so that it's in terms of y instead of in terms of x. So what I'd like you to notice here is, like I said, as we kind of think about this cross-section moving throughout the shape, we can kind of see this line created. Notice that this edge would always meet along this line from here. Oops, go through there. Okay, so do you see that this distance is always going to be going from the y-axis until this line? Okay, so this line, this is one way that I can go ahead and relate y and x. Here's my x coordinate. I just need to figure out then what's the y coordinate at that point. So let's go ahead and find a relationship between x and y based on that linear equation. So it goes up to 9 and out to 3. So we need then our equation of the line is going to be mx plus b. I see that the slope is a rise of 9 and a run of 3. So it's going to be 9 over 3. But I also see it's a negative slope. And my y-intercept, I see, is 9. So then I get, I'm going to go ahead and write it this way, 9 minus 3x is the way that we can relate x and y. And you know, if you're not real confident in that, we can go ahead and plug some numbers in. Notice if x was 0, then y would be 9. If x is 0, y is 9. If x is 3, then y would be 0. Same thing here. If x is 3, then y is 0. So we can just kind of confirm that formula. Okay, so this is my relationship then between y and x. I'm going to go ahead and write it this way, this one here. So that means if I solve this for x, I can go ahead and replace this x with something in terms of y. So let's go ahead and do that. Bring that up here. So I'm going to go ahead and add the 3x to the other side and subtract the y to the other side. And then we can divide both sides by 3 or think about taking 1/3 from both sides. Okay, so that means then that the area of the cross-section is going to be 4x squared. X is 1/3 9 minus y, and we'll take that and square it. Okay, so again, this was x. We went ahead and solved x in terms of y because the widths of those cross-sections are changes in y. So this is the thing that we want to integrate. So we want to take the integral of, we can pull that 4 out in front if we'd like, 1/3 9 minus y squared with respect to y. And notice then our bounds, we look at how our y is changing. Our y is changing from 0 to 9. So that's going to be our range from 0 to 9. Okay, so let's go ahead and integrate. And I'm going to go ahead and start by simplifying the integral here. So remember, if you have a multiplication and you're squaring it, we square the first thing and square the second thing. So 1/3 squared would be 1/9. I'm going to go ahead and pull that 1/9 out in front. And then we get 9 minus y squared. Now you could use u substitution here. I think I'm just going to go ahead and expand it out just because I think that's how most people would probably end up doing it. So I would have 81, so I'm thinking about taking 9 minus y times 9 minus y. I'd have a minus 9y and a minus 9y, so minus 18y plus a y squared. Just foiling that out. Okay, so then we get 4/9. Let's go ahead and integrate. So integral of 81 would be 81y. This would be 9y squared and 1/3 y cubed. Evaluated from 0 to 9. And let's go ahead and plug in. So I have 4/9, 81 times 9, 9 squared, 1/3 9 cubed. and minus 0. Plugging in 0 would give me 0. Just to make this a little bit easier, I'm going to go ahead and distribute this 1/9 throughout. I don't remember what 9 cubed off the top of my head is. So I'm going to divide everything through by 9. So I had 81 9 over 9 minus, this would be, you can think of these 9s canceling, giving me 9 squared, which is 81, plus one of these 9s would cancel with this, so I'd have 1/3 9 squared, which is 81. Okay, and very nicely, these 81s cancel out. And I end up getting then 4/3 times 81, and 81 divided by 3 is 27. So I have 4 times 27, which is 108, exactly what we thought we should get with the volume of a pyramid formula that we knew. Okay, so let's just recap this again real quick. So we thought about chopping the pyramid into infinitely many cross-sections. Those cross-sections had a shape of squares whose area was given by 4x squared. Since the width of those cross-sections is a change in y, we need to rewrite this area formula in terms of y. We do so by relating x and y based on the linear equation that we see, and we solve for x, replace, and then we integrate. Okay, and that's how we can find the volume of, in this case, a pyramid.